Hello, this is Dr. Oz. Today I will talk about control charts for variables. Okay, so the difference between control charts attributes was for discrete numbers or quality measures like fail or not fail or good versus inferior and so on. This part, you will not have a discrete determination, but instead you will have continuous measures. So let's start with an example here. I would like to give a coffee shop example here. Let's start with the given information. This time I will put my given information at the top. And let's look at the samples. All right. So imagine this is a coffee shop that your favorite coffee shop or coffee shop that you own, and you want to make sure that your process is in control in terms of your venti coffees. All right. Let's say to understand that randomly you take 10 samples, and then in each sample you will have sample size of 5 copies, venti copies. Copy number 1, 3, 4, 5. So in each sample you have 5 venti copies. And let's say you measure the amount of coffee in each of these coffees, and you realize that because of the iced coffee ratio, you get different numbers. So 21.6 ounces here, 21.8 ounces here, and then you got 21.2 ounces, 21.8 ounce again, 18.8 ounces. So this is your first sample. Second sample, 18.6, 21.7, 20.9, 22.4, 17.8. And the third sample, you have 22.9, you got 21.2, 17.9, 19, and the third sample you have 22.9. Oh, sorry, fourth sample you have 22.8, 18.4 ounces, 21.4, 22, 18.3. So I missed one observation here, 18.5, 19.9, 18.7, 18.5, 20.6, 18.9. And sixth sample, you got these measures, 20.5, 21, 21.9, 20.1, 23.1, 7, 24.9, 19.5, 20.6, 21.9, 16.7, 8 sample, 20.9, 19.5, 18.3, 19.8, and 21.6. Ninth sample, 20.5, 16.8. Looks like this person didn't get much coffee. 20.4, 16.5, 19.8. And finally, last sample, 18.8, 22.4, 20, 18.5, and 21.1. All right, so I have 10 samples. Each sample has 5 coffee observations, so I have 50 observations here. Now what I need to do is, first step number 1, I need to calculate the sample average. Right, so let's calculate sample average, which is, I will denote as X bar. If I take the average of the row, that will give me the sample average. First sample average is 21.4, and I got the other averages as well. And step number 2, I will calculate sample range. And I will denote this one as R, capital R. And here I need to calculate the range. So to be able to find range for this sample, I need to find the maximum of this row minus, I will find the minimum of this row. And this is my sample range. Okay, I will just drag it down. Can you see the sample ranges? All right, so I make these calculations, X bar and R. Maybe I should just really carry this one down so that I can differentiate between my model and the data. So this is my model. I calculate my X bar and R values. Now, step number 3, I need to calculate, let's calculate here. Step number 3, I need to calculate average of sample averages. And I will denote this one as X double bar. Okay, so if I take the average of averages for this data set, I got 20.21. Okay, so now step number 4. You need to get A2 value. In this case, A2 value 4, and sample size is equal to 5, because in each of my samples, I have 5 samples in each sample. So my sample size is really 5 copies per sample. That's why I will look at M5. You can look at your textbook, or you can look at online sources. I will just go to Google control charts for variables, and I got this table right here. And you can Google it and you can find the same values. I'm using SPC Excel in this case. So my sample size is 5, and A2 value is 0.577. All right, so that's my A2 value, and this is my step number 4. So now step number 5, I need to calculate my lower and upper control limit. Lower control limit. I will calculate my upper control limit. For lower control limit is, say, step 5 and 6 together. Lower control limit is again very similar to control charts for attributes. But in this case, I will look at the x double bar instead of p bar, x double bar, average of averages. And then I will subtract A2 times R. The reason I subtract A2R from X double bar is that A2 bar is a very good approximation for 3 standard deviation based on statistical analysis. So we don't need to really know how to get these values. Again, we can use the tables, but this is a great approximation of 3 standard deviation from the average of averages. Okay. So if I just change this minus with plus, I can calculate my upper control limit as well. Right? So let's calculate our lower control limit here and an upper control limit here. All right, so x double bar minus A2, right? A2 times R bar. But I need to find R bar because I haven't calculated R bar yet. So let's calculate R bar first, because I need to look at, oh, there's a typo here. It's not R. It should be R bar, average of the ranges. Excuse me. My allergies are still very active. All right, so I need to calculate my R bar. Calculate R bar here. This is the average of the ranges. All right, so now I can calculate my lower control limit, x double bar minus A2 times R bar. And my upper control limit is x double bar plus, this time, A2 times R bar. All right, so these are my control limits. But I need to specify what kind of control limit this is, because this control limit is for x bar, so for average. Also, I need to calculate my upper control limit for x bar, right? But in this case, really, I need to check whether my process is in control in terms of averages, but at the same time, the range as well. So take a look at here what's happening. So if you look at these values right here, 21 is between 1781 and 2261. This is between the lower and upper control limit. Is there anything that's greater than 22 here? Looks like not. Is there anything that's less than 17.81? No. So it looks like all these values are green, or in other words, in control in terms of these two lower control limit and upper control limit. So let's do the same judgment for the range, because I may have on average in control process, but that doesn't mean that I don't have an observations that are extreme in terms of range, or the dispersion from the center or average could be still out of control. In other words, if you are, when you think about this, is dart. Okay, so if the results are really right here, I'm trying to understand whether this is my results are here, or my results are more like this, because I can have my like blue dots here scattered all around the place, but the average could be still good. But I don't want this blue to be the case, because this is showing me that the range is way too high. On average, the process may be in control, but the range could be way too high. So that's why I would check the ranges as well. To do that, I have my D3 and D4 values, D3 and D4 values here. And these are my steps 7 and 8. Step 7, and 8. Again, you can get these values from statistical book or online. So this is from table. So let's take a look at our D3 and D4 values. So D3 is there is nothing, so I will put 0. D4 is 21, 2.114, 2.114, and this one is 0. All right. So based on this step 7 and step 8, which is D3, D4, I will calculate again lower and upper control limit, but this time not for X bar, this time for R bar, for the range. Okay. And the formula here is different, slightly different. Let's edit our comment. The formula here, lower control and upper control limit, is D3 times R bar. I will replace this by D3, lower control limit, and D4 times R bar is my upper control limit. Okay, so if I do this, D3 times R bar, which is 0, and D4 times R bar, 4 times R bar. Okay, so you can see now that my lower and upper control limits are here, and let's check whether our process is in control in terms of these two values. So D3, D4, lower control, upper control limit. My range, none of them is less than 0, that's good, and none of them is greater than 8.79, that's good. So my conclusion here is this process is in control because both the X bar, which averages, average and R bar charts are in control. Charts are in control. That's it for control charts for variables. Until next video, enjoy supply chain management.